Hello everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, September 27th, 2013. Today we have a bundle of very interesting stories, including an update, of course, on Comet Ison. What else do we talk about around here? A cool history story about the Buran, the Soviet space shuttle. Water on Mars, again. An asteroid that is actually space junk. New plans for Spitzer, a split personality pulsar, Soyuz launch, and the apex image of the Cat's Paw Nebula. And joining me this week, our intrepid team of space journalists, we've got Amy Shearer-Title.
Hello.
David Dickinson.
Hey.
Jason Major.
Hey there.
Nicole Gallucci.
Hello.
She's just rocking. Are you rocking out, Nicole?
There's music playing in the office, so yeah, I'm dancing to it. It's
All
not
right.
just in my head this time, I promise.
She's a radio astronomer. So.
And Scott Lewis. Hey, Scott.
Hey, everyone.
First, Scott, your backyard is on fire.
It's smoldering. Yeah. I was it Tuesday? No. Yeah, Tuesday. Monday or Tuesday. It went up on fire. Like crazy hot. I went outside and the foothills all on fire. Grabbed my camera, took a bunch of video, photo, sold it to NBC, and was on the news. But yeah, it's crazy. It's really intense because I used to be a firefighter. I used to leave the fire ground away and come home. I don't like it when it's towards my home.
When your work comes home with you.
Yeah, that's not good. But so far, there's been no injuries or deaths reported, which is really, really good. Last report was 250 acres went up.
Wow. Man, what a disaster.
Mm-hmm.
You get some nice sunsets, though, right?
I'm sorry?
You'll get some nice sunsets?
Sunsets?
That's true.
Yeah.
Hazy orange, yeah.
Yeah, nice hazy orange, a beautiful red sun.
Yeah, I
Filters
love
up.
having the ash all over my car. That was great.
Yeah. All right, so space news. I think, well, I want to start with what I think was one of the best pieces of space writing this week, and that is this amazing write-up on the Buran Soviet space shuttle. And Amy, you did this article over on Ars Technica, and you're always loath to give us your history stories, but this was terrific. So yeah, as we say, be loud and proud. What's the story about the Buran? And I'll try and dig up. Nicole and I will try and dig up some pictures here while we.
Yeah, if you can find images, because I'm never good at the screen sharing. But,
yeah, no, you just talk. Just focus on the talk.
I can do that. So the Buran space shuttle is the Soviet space shuttle that I think almost everyone's seen a picture of it, and the immediate knee-jerk reaction is, well, gosh darn, doesn't that just look exactly like our space shuttle, or being NASA's? And you know, that's a very logical reaction because it's the exact same shape, it's almost the same size, it's almost identical. The launch vehicle, the Energia launch vehicle, is of course not quite the same as the sort of main tank with the 2 external boosters, but it is a main tank that's almost identical to the shuttles with 4 external boosters. So I kind of dug into the story of Buran in this massive article over at Ars Technica, and what I found in researching this was that the story is so much more than just like, oh, they're building a space shuttle, so let's copy it. So NASA decided to build the space shuttle. Actually, President Nixon decided to build the space shuttle in 1972. There was sort of a whole bunch of different things that NASA was looking at doing in its post-Apollo days. And one of those post-Apollo options was building an orbital space station, and that plan included a shuttle that would, shuttle astronauts back and forth between Earth and low Earth orbit. However, Nixon okayed the shuttle, but not the space station, which is why we ended up with the shuttle doing nothing in Earth orbit. But as the shuttle developed, there were all kinds of considerations that the Department of Defense wanted, because NASA was looking for a way to make spaceflight more affordable, and the idea was to have about 50 launches per year, and that would include military launches. And the Department of Defense said, okay, well, if you make your payload bay this size, which I don't have the number off the top of my head, I think it's like 60 feet long and 15 feet wide or something, but the size of the payload bay of the shuttle was dictated by the Department of Defense because they wanted to be able to launch military shuttles. The other things, there was a launch facility to be built at oh golly, which Air Force Base was it? It was Vandenberg Air Force Base, and the shuttle had to have a 2,000-kilometer cross-range capability, which was had to do with certain missions of sort of going up into a polar orbit and coming down and being able to sort of get back in one orbit. And it all looked really suspect to the Soviets because NASA had, there was no more Cold War space race, sort of. So everything was public. So as NASA's developing this space shuttle, the Soviets are looking at it and thinking, okay, well, what are they possibly needing a vehicle this big for? They kind of did some calculations and realized, like, okay, if this thing can lift like 30 tons into orbit 50 times a year, they're definitely building something that's going to be that big. And they thought, laser weapons. So the Soviet decision actually came 4 years after NASA started building the shuttle. And the Soviets basically said, we don't know what they're doing with this spacecraft, so we're just going to build the same thing and have the same capabilities for whatever we need it for. So they basically copied the space shuttle. Now, it's not entirely identical. The big difference, the sort of most obvious difference, is that the Buran shuttle doesn't have a main engine, whereas the space shuttle does. It's also got some different avionics and systems. Buran was also designed to fly unmanned missions as well as manned missions. But, I mean, they really do look the same. They really do kind of function the same. Buran never got, it was a political mess because why build a spacecraft that's this massive when you've already got, they had the Salyut space station going at the time and the Soyuz program already going on at this time and the Mir space station was already underway at the time. Buran only flew once, and the Energia launch vehicle that launched it only flew twice. The other time was with the Polius Skiff laser article testing ground thing, which is another super sketchy, fun story. So Buran only flew once in November 15th, 1988. It flew around the Earth twice and returned, 3 times and returned. It was unmanned, and it never flew again. There was never a need for the Soviet Union to keep this thing around as long as NASA kept its around. But it was sort of, it's just this great story of Cold War paranoia forcing the Soviet Union to develop something completely unnecessary because, well, they're doing it. We should probably match that. Worst justification for a space program ever. It's so weird. It's so good.
Yeah.
They must be building lasers in space.
Yeah.
We need to build lasers too.
We don't know what they're building, but let's build something with the same kind of capability to carry stuff into space. And once that laser's deployed, we'll put a space laser on ours too.
Yeah.
Well, if Tommy down the street built a space shuttle, does that mean you have to build one too?
Yeah.
If you look for everything from that era, like the B-1 bomber and the backfire bomber and the F-15 and the MiG-25, they were all the technology was very we were following what they were doing. They were following what we were doing, basically.
Right. Yeah, well, we didn't want to have a space laser gap, so
I think somebody pointed out in a comment somewhere, I can't remember if they emailed me, but sort of the good idea that, in the same way we had the fake missile gap, there's apparently a fake space shuttle gap and a fake space gap, and all these it's just this great sort of ongoing non-gaps where everyone's just trying to match each other for no apparent reason.
It's like the Men Who Stare at Goats, where they were studying remote viewing with psychics, so we figured there might be something to it, so we better take a look at it.
We should have a sequel to Dr. Strangelove with this. I think so.
Or How to Love the Shuttle.
Yeah.
So one thing, just to let people know, the new comment track, you see, you've got this nice new thing at the bottom here, our lower third, but the actual way to track comments is we're having a lot of trouble tracking comments. So
you can't do hashtags, you can't do anything.
You can't do hashtags, you can't do searches, you can't do all kinds of stuff. So I don't know. Where do we want? We want people to go to YouTube now to talk?
Yeah, I think the YouTube comments are in the comment tracker, so I know you're watching that.
I'm not seeing them.
You're not seeing them?
No, they're not in my comment tracker.
Did you add? Because I have no way of sharing the sources anymore. So you just have to add the YouTube URL. But those will show up sort of in comment tracker.
Oh, that's not done automatically anymore.
It's not done automatically anymore.
touching
You
nothing.
still have to do it. Yeah, so I'm seeing a couple of comments. Xman049 wanted to add a related story, which I don't think was in our list. The Laddie spacecraft on its way to the moon just passed apogee, so its closest point to Earth before it heads out. I think it's taken a month to get out to the moon and study the moon's dust and exosphere environment.
Hold on, let me just do this.
Sure. Oh, hey.
Check it out. Check it out.
Wow.
Yeah, there you go.
If only we
Nice.
could actually get all our comment sources, that would be perfect.
Yeah, that would be great.
Right.
Oh well. Okay.
But I'm watching the event page since that's where I post links in real time, so...
Laddie's actually doing 3 elongated orbits like that before he heads out to the
okay.
moon. So
Okay.
yeah, another
Anyway,
one
so
coming
just
by is Juno here pretty soon. As Juno's going to be flying by too
Next month. Yeah.
next week. I think
Oh.
October 5th.
Oh wow.
Yeah.
Okay. Well, anyway, so that was a nice short version, Amy. You should definitely check out her article. It's over on Ars Technica. If you just do a search for Buran, you'll dig it up. Let's move on to the continuous coverage, our ongoing coverage of Comet Ison. Will it be the comet of the century, or will it just vaporize
Will
and
it be
disappear into nothingness?
Kohoutek? Will it be like Comet Kohoutek too?
I was thinking this week writing about it, after writing about Ison conspiracies and whatnot, now I actually get to write about Ison observing in science and the cool stuff about the astronomy about Ison, about where you're actually going to be able to see it. Right now the comet is about a magnitude fainter than it should be, but I don't really think that's really a cause for concern. It's about 11th magnitude right now. I think by the first week of October we should break 10th magnitude. I haven't actually seen it. I haven't actually been able to get out. Of course, we've got rain here and we've had a very bad summer. But I have not actually seen Ison for myself through the telescope yet. Once it reaches 10th magnitude, it should be fairly visible through binoculars and telescopes. And I think probably mid-October I'll be getting my first view. Also, what's cool is the moon is moving out of the sky. The moon is going to be heading toward new phase. The comet Ison is in the morning sky right now. It just crossed over into the constellation Leo. And it's going to be moving through Leo, then down through Virgo, and it's going to be reaching perihelion November 28th at 1.1 kilometers from the sun, from the surface of the sun. So it's going to be pretty close. Not as close as Lovejoy was, but somebody pointed out earlier this week when I was researching this article about what Ison is doing blow by blow, date by date, that Lovejoy, the comet Lovejoy from a few years ago that made its bright appearance after it came by the sun, was much fainter when it was at this distance right now than Comet Ison is. So there's still some hope, I think, that Ison's going to perform. It all depends on what it does past perihelion. It's going to be passing some bright stars, too. It's going to be passing Spica. It's going to be passing Beta Virginis. It's going to be passing toward a group of galaxies in Leo. I believe it's on October 26th. It's going to be passing toward a triple group of galaxies. That's going to be a good photo op. There's also another comet that may enter into the picture. Comet Encke is going to be right around November 23rd. This is a short period comet on a 3-year orbit. You'll probably see some astrophotographers getting images of Comet Encke, and the planet Mercury and Saturn will be up in the sky about 3 or 4 days prior to perihelion. It's going to make a good grouping low to the east. And Comet Ison is going to be a morning object when it comes back around the sun in perihelion too. It's not going to become a circumpolar object visible in the dusk sky until later in December, right around Christmas time. It's going to be moving northward up through Polaris and up through those constellations, Ursa Major and constellations like that.
Well,
so,
don't forget about being visible during the day.
They talk about that. When it's going to be really close to the sun, I think you're going to have to be able to block the sun out physically, like with a building or something like that, in order to see it. Because unfortunately, when it reaches that brightest point, it's going to be very close to the sun. So I think only probably the most skilled astrophotographers. Now, something that's interesting, I was talking to Michael Zeiler over at Eclipse Maps. There is a hybrid eclipse, an annular total, that crosses the Atlantic in Africa on November 3rd. Well-placed viewers might be able to see Ison if it's bright enough during the eclipse at that time. Now, the eclipse has got a very narrow window. Unfortunately, the totality, once it reaches totality, is going to be like less than a minute. So he was pointing out, I don't know how many people would journey to Africa to see a total solar eclipse that only lasts 40 seconds and then go look for a comet next to it. But if it gets brighter than expected, I bet somebody might be able to do a wide field shot of the corona in the eclipse sun, and Comet Ison's about 50 degrees from the sun, so it's going to be a ways. I suspect it's going to be either somebody in the mid-Atlantic on a ship, or there are also some flights going out of Bermuda that are going to observe. There's some amateur groups that are going to actually fly on a charter jet and try to observe the eclipse. at the same time. They might be able to get images too. But
I
that's
bet there'll
kind
be
of
some good images coming up out of there. I mean, you talk about who's going to go do this. There's always there's always a handful of people that are just dedicated and have the time and resources to go be able to do these types of things and get amazing images. So it sounds pretty exciting.
Lewis Hill thinks. Lewis Hill thinks we need a jingle for breaking ice and news. So
we should.
That was in my head as you guys said that. And so we need to...
Yeah, exactly. Comment of the century.
No.
We've been getting a fair amount of good amateur images too on that post. I had a lot that we could use out of the Universe Today Flickr group, and there are some dedicated amateurs with telescopes much bigger than mine that have been able to get after it and get some images.
Well, and Hubble's going to be covering it as well.
Hubble's going to be imaging it. It's passing Mars on October 1st, so we may see, probably next week we'll be talking about whether or not MRO with HiRISE and the Curiosity rover probably will have tried to image it, which will be the first time we've imaged a comet from the surface of another planet, which will be
would be awesome.
Yeah.
That's freaking amazing.
Story idea, if anybody wants to. That's probably coming up.
Yeah, it's all you. All right, so let's move on. Actually, this is great. So apparently, this just in, there's water on Mars.
What?
And I've also heard that Voyager has left the solar system.
But for realsies this
No,
time.
it's not left the
On
solar
no
system.
account.
For realsies, and now. That's the thing.
All right. So Scott, what is this nonsense story about water on Mars?
And, there's water on Mars. Well, as many of actually us that are in this hangout now we were there for the landing of Curiosity last year in August, and one of the instruments on there is SAM, which is the sample analysis at Mars, and it's been going through doing its test driving, and it did also some tests at this really neat location called Rock Nest. So it was going through some samples, and what I love too is that the quote pulled from this Discovery article by our good friend Ian O'Neill. The quote by Lori says, "One of the most exciting results from this very first solid sample ingested by Curiosity," because Curiosity is eating stuff.
It also poops.
And it poops.
Yep.
So I think that's awesome. But what it was going through when it was doing the analysis through SAM is that it was able to pull out. Doing the analysis, it's able to pull out that there's oxygen available in this analysis here, but also signs of perchlorates and carbonates, which carbonates, the carbonate materials, they only form in the presence of water. So they're saying here with this analysis coming out that around 2% of the soil that they were sampling there had water in it. So instead of just guessing, or we assume that there was water at some time, or finding different evidences, that they were able to actually find chemical analyses of finding these carbonates that must form in the form of with the presence of water there.
So when future Mars travelers go there, they just know, they can calculate exactly how much regolith they'll need to grind down to drink their liquid.
Right. So you're going to go there, dig a ditch, sweat it all out, and then heat it up and get the water out, and then you're fine. Something easy.
So, I mean, put this into perspective. Amy, I know you're working on this story as well. I mean, the larger perspective here is they're trying to really understand the conditions on Mars. Is it available for life? Not looking for life itself. So.
Yeah. Well, what I've seen, and I'm sorry, I'm still working on the article, but the water that they found, or the evidence of water they found, is actually 2% by weight. I'm not totally sure what that means and whether or not that has any impact on how much and how easy it would be to get out, but it's still not as nearly the amount that is in sort of locked under the surface in ice form. So I don't really know. I mean, if astronauts were to go there, would it be worth trying to siphon out this very small amount of water from soil? I forget. I saw somewhere a great, how much water you would need or how much soil you would need for a pint of water. I'm trying to find that. But it might make a lot more sense to send astronauts with the tools that they would need to dig into that ice where there's significantly more water, or ice that could be made into water. So Yeah.
Yeah,
I don't.
agree. don't
I
think it's
can't really say what this would mean for future astronauts, but it is really cool.
I'm wondering if there are going to be different concentrations of water depending on the type of soil that they see across different regions of Mars. So they sample, for example, the soil that's in Gale Crater. Maybe it's looser, maybe it's sandier. What happens if they go somewhere where there's a denser soil that has smaller pores in it, like clays and things like that? Will it have a higher concentration of water in there? I know they did say that the samples that they took are supposedly indicative of perhaps a wider area across the entire planet because it's wind blown. So because it's just in that top layer. So this is what's getting blown around. You just have to wonder, what about different types of materials? Maybe they hold more water. Maybe they're more than 2%. Maybe they're 5% or 3% or 10%. Who knows?
Right, and with the lack of atmosphere there on Mars, anything on the surface is going to be negligible than anything below the surface, because without without the atmosphere there, anything will evaporate away. And so they're just saying that the signs there from the carbonate there show that it formed at some time because there was water present, and that this particular compound with there. But I definitely would say keep on digging. You might want to bring you want to dig a well. Might be the best way. Then you go through and scooping up the sand.
They would have to move a lot of rock to
Yeah.
get just a tiny amount of water, like on the moon too.
Wasn't there some? I'm remembering some made-for-TV movie or show or something where they were trying to drill for water on Mars, and then when the water geyser happened, it was disastrous because it was all turning into ice and killed one of the astronauts.
Wasn't it
Someone in the
Total Recall?
comments will remember that. No, it was like some first human settlers sent to Mars, made-for-TV thing in the Mission to Mars genre. But I think it was on Discovery or something. Anyway, I'm going to move on. So let's talk about Jason. I want to talk about this split personality pulsar. And in Universe Today, I don't know if you saw, Elizabeth said it was that it was hulking out.
It was like the Hulk. Yeah, I saw Elizabeth's article there. That was great. She likened this pulsar, this neutron star, to the Hulk. Go from Dr. Banner to the Hulk, and that's kind of what's happening here. Although another analogy that's been given is it's kind of like a teenager all of a sudden acting like an adult, and then going back again and then back and forth. What astronomers have found I'm trying to think of the right term here. It's globular cluster or globular cluster? Somebody correct me.
Globular.
We know what both are.
Yeah. Okay, so in a globular cluster, 18,000 light years away towards the center of a galaxy, they found it's a neutron star. It's a bright X-ray source. So what this is, it starts off as what they call a low-mass X-ray binary. It's a neutron star, and I've got some AV guides here. So you got this neutron star, which is the super dense remains of a good-sized star, bigger than our sun. So and it's rapidly spinning, and it has an accretion disk around it, and the accretion disk is coming from its buddy, which is a low-mass, sun-like star that's nearby, and it's basically slurping off material from this star, and it's going into a disk around the neutron star. And that disk gets superheated, and it just starts shooting out X-rays that are detectable by X-ray observatories like NASA's Chandra, like ESA's XMM Newton. So they can see this thing, and it's glowing brightly in X-rays. But then what happens is it shuts off, and it starts shooting out radio waves from its poles. It's spinning, 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 and it's spinning up to 254 times a second. So that rapid rate makes them call it a millisecond pulsar. So switching back and forth has never been seen before. Not in this short time span. Basically, they're looking at it's doing this every few days or so. So the important thing that's happening here is they're seeing what's kind of a missing link in the evolution between a low-mass X-ray binary and that millisecond pulsar. Generally, what's the structure that's going on there is this accretion disk gets blown away as it heats up, and I'm trying to think of the actual process that's going on here. So you've got the secretion disk around the pulsar, and it's just emitting X-rays like crazy. As the neutron star picks up more material from the disk, it also gets spun up. And the neutron star has a really strong magnetic field. So as it's spinning, that magnetic field starts to throw out all of the material that's left in there, because the stuff that's getting pulled off of the larger low mass star, that trickles down. It's not always coming in at a constant rate. So once it gets rid of all this bright X-ray stuff, it's able to shoot out basically the radio waves from its poles, and as those sweep by our point of view, we see it as a pulsar. So what's really cool is that this hasn't been seen before. So it's kind of like one of these missing link type things. It's a process that's known to take place in the evolution of a neutron star from the X-ray binary to the millisecond pulsar, but that in and of itself takes billions of years. What they've finally seen here with this one is the process taking place, and they can see it switch back and forth. So it's kind of like, switches on, switches off. It's X-ray binary, it's a low mass X-ray binary, it's a millisecond pulsar. So that's the whole kind of idea of how it's one thing, it's another, it's David Banner, it's the Hulk, just goes back and forth like that.
It's a teenager, it's a adult.
Scott Ransom of the National Radio Astronomy Observatory called it Jekyll and Hyde, but I think he should have adopted Banner and Hulk.
But really, the important thing here is actually seeing the process taking place right in front of us. It's kind of like what happens when you sneak downstairs and see mom and dad putting gifts under the Christmas tree. I mean, you're seeing this magical thing happening.
Spoiler alert! I hope there aren't any little children watching.
Why? What happens when they do that?
Spoiler alert.
See, Santa's really a binary star system. That's all.
That's exactly what it's like.
Millisecond pulsar.
Yeah. That's how he's able to get to all the.
They're going to find out somewhere. I'd rather it be here.
I'm with you, but I'm the one who always gets in trouble, so.
All right, we're moving on.
And the cake is a lie.
What? The cake is not a lie. All right, so David, let's talk about an asteroid that is not an asteroid.
Yeah, there was an interesting discovery on August 23rd from the Pan-STARRS survey. It's based in Maui in Hawaii, of an asteroid that they had tentatively dubbed 2013 QW1. Now, that kind of discovery wasn't anything unusual per se from what we usually see, but this one was found to be in a very wide-ranging Earth-trailing orbit, and that's not something we generally see an asteroid do. There was an asteroid a few years ago that kind of had the same kind of story as this one, too. That was dubbed J002E3. That was back in 2002. Now, some European researchers decided to analyze this asteroid a little closer using the Galileo telescope out of La Palma, and they actually found that it had a very bright signature, a very bright spectra that was very uncharacteristic of an asteroid, but was characteristic of a painted metal object. And it turns out that this asteroid is actually a Stage 3 booster from the Chang'e 2 mission that China had launched to the moon back in 2009. This mission orbited the moon for about a year. It went out to the Earth's L2 point, and then it went on to pass asteroid Toutatis a few years ago. It was the first mission that actually got close to asteroid Toutatis and got photos of that NEO asteroid.
So you can see drawing here, David?
That is me in paint putting on the markers of where the Stage 3 booster is. Actually, on the that's a Long March 3C rocket. That is actually the launch of Chang'e 2. I actually dug that up from the Chinese Space Agency. That's actually that one's not just a generic launch of a Long March C3. Now, the asteroid they found back in 2002, that one they found had a spectra of titanium oxide, and they did some researching and they found out that titanium oxide was derivative from the paint from the old Apollo boosters. And what that was a Stage 3 of a Saturn V rocket, and they actually managed to pin down which mission, the one that they found in 2002 that was orbiting the Earth for a time, that came around where they said Earth has a second moon at that time. There was a story, and I actually looked back in the Universe Today archives. you wrote about this back in September 2002 about this same asteroid turns out to be space junk story.
Did I?
Back then.
Wow.
Yeah, it's way back before we had
You've been around
blogs.
for a while, Fraser.
I have been doing this for a while.
I thought of that right before the show. I was like, I wonder if he has the same story way back when. There, it looked like it's been migrated over from the website, but you actually had written about that same Apollo. It was the third stage of Saturn V of Apollo 12. Was actually one of the few boosters. Most of the boosters smashed into the moon. They used them to steady seismic experiments that they had left on the moon from Apollo 11. The subsequent boosters, and that actually is the launch, the famous Apollo 12 launch that got struck by lightning, and that's actually the stage booster that's out there. Incidentally, it's not orbiting the Earth anymore. It got kicked out of orbit in 2004, and probably is going to come back around in 2040 right now. So. Anything that gets put in orbit around the Earth, the wide-ranging orbit like that, the moon is more likely to kick it out. But it would be cool if they found a second asteroid moon of the Earth, but thus far none has ever been found. There's been theoretical discoveries even before the dawn of the space age, where people had thought they had found satellites of the moon or second moons of the Earth, but they've never turned out to be anything substantial.
Yeah, I actually did a video on this, and there's an article on this that I did that sort of covers that, and all of the objects that are kind of moony and sort of moony, but none of them are actually. There's
one called, I think it's pronounced Corinthi, and it's in a horseshoe orbit. Cruinia.
It's Welsh, I think.
It's a pseudo moon, and Venus has a few of these too that I've written about. It's a quasi-moon of the Earth. It's not actually orbiting the Earth in a traditional sense, but it's in a resonance, an Earth-crossing resonance with the Earth. And some are in horseshoe orbits too, where they approach the Earth from behind, and then they kind of lag behind, and they start moving around, and then it's kind of a complex. Unless you see the actual graphic of a horseshoe orbit, it makes no sense. The first time I had written about it, I'm like, I don't quite understand this till you actually see one in motion of how it works. Like, I get it now.
Does that mean there's space ponies if there's horseshoe orbits?
You never know.
I think there's space ponies.
There should be.
So before we move on to the next story, Nicole would love there to be space ponies. Pony lords, jump for your lives. Okay, there is. Amy did a little research here and dug up a piece of information here. So let's just go back to it here.
Oh, water on Mars?
Yeah, come on, hold on. There it is.
Yay. Yes, so I did find the reference. For every cubic foot, which is 0.03 cubic meters of Martian soil, you can get 2 pints of water.
I'm sorry to say you were beat. You were beat to that by Will-eyed Oney.
Mine came up
before you. Oh no, it is
really?
came up first on mine.
Oh, okay.
Oh, sorry.
It was pretty.
But thank you, Will,
before I saw his.
But that's, I mean, that's not a
finding
lot.
the same reference online.
I mean, you could get out there and shovel for a couple of minutes and dig up a bucket of regolith and and then stick it on your Martian stove and heat it up, and a couple of pints of water will percolate out the bottom.
Well, then is it potable? And then how much energy is needed to make it potable?
Well, isn't it perchlorate? Isn't it coming out of perchlorate, which is poisonous, right?
Yeah.
So.
Yeah, I guess that's the next step of whether or not.
Yeah, you have to get into the economics of it.
Then you would have to distill it, and then you'd
Right.
We need to send the von Neumann meter out of it.
Martian moonshine next.
Of course, once it's exposed to the Martian atmosphere, wouldn't it just kind of like boil away instantly?
Yeah.
Right.
So you gotta like leave. You're just gonna stick your straw down into the soil.
Well, I just imagine the percolator and catch as much as you can.
I'm just imagining it like, you know, like people are on these Arctic expeditions and they have this little stove and they grab chunks of ice and they heat it up, and then that's their water, and they make their tea from it. So it's going to be the same thing, except the Martian explorer's going to go outside. They're going to dig up a bunch of
perchlorate.
Yeah, they're going to dig up a bunch of dirt.
Tablets you can put in there. There's little tablets you can put in to make it, you know,
right.
collect some of the crap.
Like iodine tablets or whatever it is.
Thank you. Iodine tablets. Thank you.
Crystal Light. You got to mix it with some Crystal Light. Get rid of that nasty Martian flavor.
They need to design a straw.
Filter.
You can put dirt in one end and water will come out the other.
Mission to Mars, sponsored by Brita.
Okay, I think we're doing a show here. Let me see.
No.
This is the show.
This is the show. This is what people come for.
Yeah.
They want our nonsense. Yeah. You know what? Let's raise the level of professionalism. Let's go to the most professional person on the entire team, and that, of course, is Dr. Nicole Gallucci,
Me?
the only one here with a PhD.
And a pink pony.
That fares well for all of us.
So raise our standards,
Well,
Nicole, and talk
first-
about the Cat's Paw Nebula and the new Apex instrument.
I will, but first we got a comment from Hugo Burnham asking how much water would you get from a cubic foot of Earth's regolith in comparison? So somebody look that up while I do this story.
All right.
Because I'm curious as well. And I guess it depends on where you are.
Yeah, that would depend when, because you get it from a
If you're
bog,
like in the Sahara or if you're like, in Florida.
because we have an atmosphere.
Okay, so, but we're going to talk about sub-millimeter telescopes. So this is the really high end of the radio telescope spectrum. This is APEX, the Atacama Pathfinder experiment. It is a single-dish telescope out in the Atacama Desert at 16,700 feet. So it's at that site where I went and visited, and there's not a lot of oxygen up there and get really dumb. But you have to be smart enough to do the astronomy. And they were testing a new instrument called Artemis, and Artemis is actually a bolometer array. So it's more like a CCD that you would have on the back of an optical telescope, and that it has many, many pixels. And so it is a better imaging instrument than you would get for when you normally think of having a single dish radio telescope. So this bolometer array on the back end was used to image the Cat's Paw Nebula. Oh, good, you're showing it. Sweet. That saves me extra work. And so this gorgeous image here is showing the orange, which is the emission picked up by Artemis, by Apex. It is put on with a visible image, and the visible light image, you have all these dark patches, and those dark patches you can't see through unless you go to the sub-millimeter, and this is the light that lets you see through these dust clouds to the cores of forming stars. This is a star-forming region, and so we can actually map how these young stars are forming. So this was like I said, just the first image. It was just kind of a test. It wasn't, I think, a big science study that came out of it, but it looks like it's like flames. It's really cool. So this is the bolometer array called Artemis on the back end of Apex, and so they're looking forward to doing really great sub-millimeter science once this is fully commissioned and or I guess it's fully commissioned now once it's fully running.
Now, I did hear that they're going to be sending that Artemis is going to be going back for some more calibrations, and then before it actually comes back and gets assembled onto Apex permanently.
Okay, so it is
So
still
this is
commissioned.
so imagine that. I mean, this is gorgeous, and this is a test image.
Yeah, very cool.
Now, have you actually seen this instrument or this observatory up
No,
close?
I think I saw it from the bus on the way when we were up at the site, the Alma site. I didn't actually get a chance to see it. So, is that a picture?
That's the
the
instrument
on the
itself,
back
yeah.
end? Very cool.
Yeah.
So I don't know nearly as much about bolometers as I wish I did, but I know that they're really, really fascinating instruments, and so this is 2K pixel camera basically being used on a radio telescope.
Awesome.
Very cool.
A few quick stories. There was a Soyuz launch this week. David.
Yeah, there was the next expedition went up to the ISS that went off Wednesday, I believe it was, and it was a fast track launch too. That one went out of Baikonur, and it was a 4-orbit, 6-hour rendezvous with the ISS. Those are becoming more common, but I think it was you, Jason, that said that it actually took the families. I saw you on Twitter saying it took the families longer to get back to Moscow from Baikonur, or the capital there in Kazakhstan, than it did for the astronauts to get up to the ISS. So,
which is why they stay there until the astronauts arrive and they dock and open the doors and everything instead of going back to Moscow.
I didn't watch the docking live, unfortunately. It was a little past my bedtime. But the booster is going to be re-entering. I'm tracking that on Space Track right now too. Booster should be re-entering here in 24 hours. The Soyuz booster that actually put them up there is still in the general orbit of the ISS right now. So usually that comes down within a few days. But they're going to be up there until, I believe, March, when they're going to do the next swap out. And this actual Soyuz is going to be doing duty as a lifeboat up there. I think they're going to swap it around it docked on the Poisk module of the ISS, but they're going to actually swap it over here pretty soon. And we're actually.
I'm going to try an experiment here. I hate to do this. I'm going to try something. I'm sure this is going to wreck the whole hangout, but here we go.
the Cygnus module will be docking too. That's still up there. They waved it off for a technical problem a few days ago.
They're going to dock Saturday, right? Tomorrow.
They're going to try to dock. I believe it is tomorrow. So it's a busy time up there at the ISS right now. Once they had the problem with the software issue on the Cygnus, they were waved off until they could get this scheduled Soyuz launch up there and docked. And now they're the next thing in the pipeline going to the ISS. Oh, cool.
Speaking of a busy time up there, at the beginning of November, there's going to be 9 crew members aboard the space station. Yeah, there's going to be an overlap there. There will be 9 crew members aboard, and there will also be, for a brief period of time, a Winter Olympic torch.
I saw that too.
Space station. Yeah, that's so they're going to, it's going to spend some time up in orbit before the expedition comes down and they get ready for 37, 38.
And it gets the world record for the high jump.
Oh, very cool. I like watching these Soyuz. I like watching these Soyuz launches because you can actually get the in-cabin view like through the entire time when they're going up. Unlike the shuttle launches where you don't get that in-cabin view. I think it's kind of cool.
Mm-hmm.
And they always go on time. I've never watched all these Soyuz launches I've watched. I've never saw one where they've been delayed for anything. They always go on time.
Regardless of weather, it can be.
We watched one in a snowstorm. There was one in a snowstorm one time they launched. Yeah, it was like, that's pretty amazing.
You could barely see the pad, and there it is. It took off.
Yeah.
That's really cool. I would love to watch one of those live. It seems like it's so, like, if you've ever been to the NASA Kennedy Space Center, there's like big crowds and there's like lawn chairs set up, and it's a very, I don't know,
if you go to a launch event. If you go to a launch at KSC, if you're at the press site or if you're at the Causeway, you're still about 3 to 5 miles away. Mm-hmm. You watch these ones from Baikonur. We see trucks driving around seconds before the launch up by the pad sometimes.
Yeah, it's just business as usual. They're moving around doing and there's a rocket launch.
Oh yeah, we're just going to space.
Just going to space. Pull up another train, get another rocket on the pad. Yeah, it would be quite something. I agree, Amy. We all need to go to Moscow and then to Kazakhstan.
Field trip.
Field trip.
Let's go.
Road trip.
Yeah.
What are the roads like in Kazakhstan?
About armadillos or frogs or anything like that.
We need to make sure we have dash cams on all of them just in case there is another asteroid or another asteroid coming in.
Indeed.
Okay, Amy. Spitzer is going to have a new job.
Yes. So over the last few months, as we've all been quite sad that Kepler has sort of passed on to its non-planet hunting life because it's lost its ability to focus, there is a new player in the exoplanet hunting game, and that is Spitzer. NASA's Spitzer Space Telescope is one of the 4, what is the formal thing called? Sorry, I wasn't prepared. It's part of with Hubble and the Chandra X-ray Observatory, and I forget the name of the other one. It's designed to look at the universe in 4 different wavelengths, and Spitzer looks at the universe in infrared light. And it's been doing that for about 10 years, which is pretty good because it was only ever designed to last for 1.5 years, and its mission was extended to 5, and it's still going. And this has a lot to do with some really clever engineering by the team. They sort of built in backup ways to cool the telescope and its instruments. It's got cryogenic cooling. It's very weird, and I don't totally understand how it works. But they've been able to actually repurpose some of its instruments to make it a really good exoplanet hunter. So the key in exoplanet hunting is, of course, being able to look very precisely and not very, steadily at a distant point of light, at a star, and look for these sort of dips in light as a planet passes around it. So what this team behind Spitzer has done is actually repurpose one of its not its primary camera, but its secondary camera that it used to pinpoint and figure out where to point the primary camera in its previous life. They've repurposed that and taken the data from that much more. It's a much more sensitive camera, and then feed that data into its infrared instruments, which means that now Spitzer can not only look for exoplanets, it can look for exoplanets in the infrared light. And this is interesting because everything emits infrared radiation, including exoplanets. So Spitzer's Spitzer's instruments allow it to actually look at the composition of exoplanets, and as they go around the side of their star, the telescope can actually gain some information on the world's overall temperature. So it's a pretty interesting our piece of equipment in our arsenal against finding exoplanets.
Until the gyroscopes go.
Until something else goes on this. But hopefully it'll, I mean, it's done really well. It's way outlived its primary lifetime, so hopefully it'll last maybe until James Webb gets up there. Maybe not. Probably not. But
Spitzer's been great.
Let's hope that it actually...
I think James Webb is 2017, I think it's
2018.
2018. Yeah. It keeps sliding back.
It keeps slipping, doesn't it?
Ish.
Now, before we wrap things up, I want to share an image that we posted on Universe today, and it is unbelievable. So that's not it. That's not the image. That's turtles all the way down. Hold on.
You are now in the Hangout. Within the Hangout.
You have been.
In the Hangout.
All right, here we go. So this is the size comparison of science fiction spaceships, and it's hard to get a sense. And I hope you've all got this turned to the high def version of your Hangouts, because this is in YouTube, because this is unbelievable. So I'm going to zoom in a bit here.
I see Darth Vader's Star Destroyer.
Yeah. So what do we got? Right. There's a Super Star Destroyer.
Yeah.
I
haven't seen the battle.
The Executor.
The Executor.
Yeah.
Yeah. We've got stuff from Warhammer, from the Warhammer 40,000 world.
Is that the Death Star at the bottom?
I think so.
Yes.
There's got to be a Battlestar on there, but I don't see him.
There's from Lex. Do you guys ever see Lex? I think it was a Canadian thing.
Yes. Oh, I've seen Lex.
Yeah.
That show was hilarious.
So weird. Stuff from. Let me see what else we got. Stuff
from
Wing
there's
Commander.
Stargate. Look. There's the Stargate.
All the Stargate ships.
Yeah, the motherships, the gold motherships.
Yep. Stuff from Robotech.
What's the big flying tree?
Big flying tree.
It's right up there. It's bigger than the Star Destroyer.
Is it? Wait, a flying tree?
It looks like one there, like.
Oh, on its side. Okay. I was
side.
That's not the one from Saga.
I don't know what it is.
Is it? No.
Is the Yamato in
Eve?
there from
Is that the?
Oh, Eve. That's the big one.
Is that the Erebus class Titan from Eve? Maybe.
Oh, cool.
I played Eve
No, the
online.
brown one under it, I think. The brown one under it looks like a tree.
Yeah. I don't know. I think that
I'll have to
is.
scroll around that now.
Serenity is not on there.
What?
I think it would
know
be like
it's sad.
it would be like a pixel. I mean, they could.
Well, there's some stuff in the very top corner here that we can check out. Here, hold on.
Or at least I haven't been through it all, but according to my boyfriend, Serenity is not on there.
Oh, really? There's a lot of stuff from Eve Online, which.
That could be a great poster.
Oh, look, there's a Valen ship.
I didn't see anything from
Stuff from Babylon 5.
It's the Babylon 5 ones.
Yeah.
I'm sweet.
Where's Spaceman Spiff's cruiser?
Yes.
Anyway, I'm sure. So if you haven't already, just dig through that and just feel all the sci-fi nostalgia as you look through these images. It's just terrific. Wonderful. Okay. Well, now is the time when we start to wrap this show up. But before we do, I want to give everyone a chance to shamelessly promote things that they're working on. So let's start with you, Amy. Now, we've already shamelessly promoted your Buran article, but anything else that's happening? And where can we find out more? Amy, share title.
Sorry, your audio went all wacky there. Are you telling me to promote things?
Yes.
Yeah, promote things.
I'm not working on anything super exciting right now, I don't think. Go read my Buran article because I'm really happy about it. Yeah.
All right, but people can find you. Do I have to do this for
also,
you? People can find you at AST Vintage Space on Google Plus and your blog Vintage Space.
Yeah,
you also blog for I forget. Anyway, let's move on.
Yeah.
Everywhere.
You had your
Go
chance.
to my
Okay.
website. Go to just Google
Any
Vintage
blog
Space,
for
you'll
the
find it.
internet?
Yeah. Just check the internet. You might be able to find it.
Do people still blog? Is that still a thing?
It's still a thing.
Oh, Cyril Villa made a good point. He just put Fermi. I don't know whether he was talking about whether some of the NASA spaceships are any real spaceships on this.
No, that was before that image.
Oh, he was talking about right. Okay.
Oh,
okay,
that's the fourth. That's the fourth observatory.
I think it was Compton Gamma Ray Observatory.
Which is
I think Compton and Fermi are different. I think. I'm not certain, but.
Oh my
Yeah.
God. My high energy friends are gonna kill me.
Straight out of
Compton's been because Compton was
Compton.
deorbited.
Yeah, the great observatories were Chandra, Spitzer, Fermi, and Chandra, Spitzer,
Hubble.
Guys, there's an internet for
Hubble, and
Hubble, Compton,
Compton.
Chandra, and Spitzer, not
yeah.
Fermi.
Compton
yeah.
was deorbited in 2002, though. It's not up there anymore.
Yeah, but it was one of the great observatories.
Yeah.
David, where do we find out more?
See, this week I was active on Astro Guys on my site, Universe Today, Listosaur, Canada.com, and I will be doing an in-person star party for my next event tomorrow night at Starkey Park. So if you're in Pasco County or around Tampa Bay, come on out. It's free.
I've been there. It's a good time.
Yeah. That's the first place I ever met Jason, as a matter of fact.
Nice.
I tweeted that out. Oh, cool, I'll be over. I was like, you're in the area? It's like, no way.
Even better than hanging out online is hanging out in real life.
Meet space.
IRL.
IRL.
We can watch Space Junk pass over in person.
Oh, that's great. Jason Major, where do we find out more?
I'm at lightsinthedark.com. I'm also writing at Universe Today and Discovery Space News, and you can find me on Twitter at JPMajor. Also, a little public service announcement. Over the past few weeks, I've been having a hard time with my MacBook Air. Turns out I had a bad battery. It slowed down like crazy. So I found out that you're not supposed to fix them yourself, but you can fix them yourself. So I ordered the parts, figured out how to replace the battery, which ended up being really easy as long as you have the right tools. So I put a little how-to up on lightsinthedark.com. So if anyone else is having the same problem that I was, where their MacBook was just running slow as anything, you might need a new battery. So go run over there, lightsinthedark.com, and check out my how-to and where you can find the pieces for that.
I think I need to follow that how-to. In fact, I had a little warning come up on my MacBook Air saying that my battery was having problems. So
yeah, you know what? They don't. The law of entropy hits them hard, and they don't live forever. So And I also left mine plugged in a lot, and that's also not good for your battery to just keep running it plugged in. So yeah, you get a new one, and let me tell you, it just basically night and day. It's working great now.
That's awesome. Okay, well, thank you very much for that.
No problem.
Dr. Nicole Gallucci, where do we find out more? What would you like to shamelessly promote?
All the things. I work at CosmoQuest, so come do citizen science with us. I just sent out a newsletter blurb with the current state of all our projects. So we are still looking for people to map the surfaces of Vesta and Mercury and even the Moon, even though our first paper's coming out on that really soon. And then I am at noisyastronomer.com. You can get to all my other blog stuff that I do from there. So I blog for Skeptic and Discovery Space and School of Doubt. So yeah, come say hi.
And people will be able to say hi to you in person shortly.
People can say hi to me anytime if you want to come to Southern Illinois and hang out. I also do in-person star parties every other week, so come on down. But yeah, I'm going to be at Geek Girl Con October 19th and 20th, I think. The schedule just got posted, so I'm doing an edible astronomy panel, and I'm doing a careers in science panel, and I'm a part of Dr. Rubidium's Do-It-Yourself Science Zone. So we're still raising money to get that completed. I'll post a link in the comments, but if you search DIY Science Zone Geek Girl Con, you will get one of our posts where we beg you for money. And then in October, the weekend before that, October 12th and 13th, I'm going to be in Boulder. Phil Plate, Marcella Setter are doing the Boulder Science Festival, and so I'm making comets out of dry ice and in a safe manner. So it'll be a good time. So come say hi.
That'd be great.
Yeah.
Scott. More Scott. Where?
More Scott. I'm at knowthecosmos.com. On Twitter, I am Bold Astronomer. I am also doing all the things. Let's see. I do Space Fan News, which will be coming out either later tonight or early Saturday morning with Tony Darnell at Deep Astronomy. Also working with the Hubble Space Telescope team with their Hubble Hangouts. And the virtual star party is this thing that happens on Sundays with some people. So where we connect a bunch of telescopes up and look at the universe in a Google Plus Hangout. So Fraser and I co-host that, and we take over the interwebs. Now that Breaking Bad and Dexter and everything like that's gone, we
have one more night. No, we got one more night.
One more night.
We're going to conflict with Breaking Bad one last time.
DVR it. We're live. You can always watch. The story's not going to change with those, trust me.
And I want to give one quick thank you, which is that the YouTube channel that you're watching right now just crossed the 10,000 subscriber mark.
Woo!
So thank you everyone who has subscribed to this channel.
We're doing something right.
We're doing some. It's great to see that you all love space and we really appreciate it. And so
Thank you for your kind and sincere comments.
And
Yes.
your wonderful support, and yeah, and you improve YouTube greatly. So we really appreciate it. All right, so but if you haven't already, you could subscribe and then make it 11,000. So thanks everyone for watching, and we will see you all on Sunday night for the virtual star party, because you're going to skip Breaking Bad.
Yeah, skip Breaking Bad. Go watch the VSP.
All right, thanks everyone.
Department of Defense wanted, because NASA was looking for a way to make spaceflight more affordable, and the idea was to have about 50 launches per year, and that would include military launches. And the Department of Defense said, okay, well, if you make your payload bay this size, which I don't have the number off the top of my head, I think it's like 60 feet long and 15 feet wide or something, but the size of the payload bay of the shuttle was dictated by the Department of Defense because they wanted to be able to launch military shuttles. The other things, there was a launch facility to be built at, oh golly, which Air Force Base was it? It was Vandenberg Air Force Base. And the shuttle had to have a 2,000-kilometer cross-range capability, which was had to do with certain missions of sort of going up into a polar orbit and coming down and being able to sort of get back in one orbit. And it all looked really suspect to the Soviets because NASA had, there was no more Cold War space race, sort of. So everything was public. So as NASA's developing this space shuttle, the Soviets are looking at it and thinking, okay, well, what are they possibly needing a vehicle this big for? They kind of did some calculations and realized, like, okay, if this thing can lift like 30 tons into orbit 50 times a year, they're definitely building something that's going to be that big.
Hello, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, September 27th. 2013. Today, we have a bundle of very interesting stories, including an update, of course, on Comet Ison. What else do we talk about around here? A cool history story about the Buran, the Soviet space shuttle. Water on Mars, again. An asteroid that is actually space junk. New plans for Spitzer. A split personality pulsar. Soyuz launch. And the apex image of the Cat's Paw Nebula. And joining me this week, our intrepid team of space journalists, we've got Amy Shearer-Title.
Hello.
David Dickinson.
Hey.
Jason Major.
Hey there.
Nicole Gallucci.
Hello.
She's just rocking. Are you rocking out, Nicole?
There's music playing in the office, so yeah, I'm dancing
right.
to it. It's not just in my head this time, I promise.
She's a radio astronomer. So.
And Scott Lewis. Hey, Scott.
Hey, everyone.
First, Scott, your backyard is on fire.
It's smoldering. Yeah. I was it Tuesday? No. Yeah, Tuesday. Monday or Tuesday. It went up on fire. Like crazy hot. I went outside and the foothills all on fire. Grabbed my camera, took a bunch of video, photo, sold it to NBC, and was on the news. But yeah, it's crazy. It's really intense because I used to be a firefighter. I used to leave the fire ground away and come home. I don't like it when it's coming towards my home.
When your work comes home with you.
Yeah, that's not good. But so far, there's been no injuries or deaths reported, which is really, really good. Last report was 250 acres went up.
Wow. Man, what a disaster.
Mm-hmm.
You get some nice sunsets, though, right?
I'm sorry?
You'll get some nice sunsets?
Oh,
Sunsets?
That's true.
Yeah.
Hazy orange, yeah.
Yeah, nice hazy orange, beautiful red sun.
Yeah, I
Filters
love
up some.
having the ash all over my car. That was great.
Yeah. All right, so space news. I think, well, I want to start with what I think was one of the best pieces of space writing this week, and that is this amazing write-up on the Buran Soviet space shuttle. And Amy, you did this article over on Ars Technica, and you're always loath to give us your history stories, but this was terrific. So yeah, as we say, be loud and proud. What's the story about the Buran? And I'll try and dig up. Nicole and I will try and dig up some pictures here while
If you can find images, because I'm never good at the screen sharing. But,
yeah, no, you just talk. Just focus on the talk.
And they thought, laser weapons. So the Soviet decision actually came 4 years after NASA started building the shuttle. And the Soviets basically said, we don't know what they're doing with this spacecraft, so we're just going to build the same thing and have the same capabilities for whatever we need it for. So they basically copied the space shuttle. Now, it's not entirely like identical. The big difference, the sort of most obvious difference, is that the Boron shuttle doesn't have a main engine, whereas the space shuttle does. It's also got some different avionics and systems. Boron was also designed to fly unmanned missions as well as manned missions. But, I mean, they really do look the same, and they really do kind of function the same. Boron never got, I mean, it was a political mess, because why build a spacecraft that's this massive when you've already got, they had the Salyut space station going at the time, and the Soyuz program already going on at this time, and the Mir space station was already underway at the time. Boron only flew once, and the Energia launch vehicle that launched it only flew twice. The other time was with the Polyus skiff laser article testing ground thing, which is another super sketchy, fun story. So Boron only flew once in November 15th, 1988. It flew around the Earth twice and returned, 3 times and returned. It was unmanned. I can do that. So the Boron space shuttle is the Soviet space shuttle that I think almost everyone's seen a picture of it, and the immediate knee-jerk reaction is, well, gosh darn, doesn't that just look exactly like our space shuttle, or being NASA's? And, you know, that's a very logical reaction, because it's the exact same shape, it's almost the same size, it's almost identical. The launch vehicle, the Energia launch vehicle, is of course not quite the same as the sort of main tank with the 2 external boosters, but it is a main tank that's almost identical to the shuttles with 4 external boosters. So I kind of dug into the story of Boron in this massive article over at Ars Technica, and what I found in researching this was that the story is so much more than just like, oh, they're building a space shuttle, so let's copy it. So NASA decided to build the space shuttle. Actually, Nixon decided to build the space shuttle in 1972. There were sort of a whole bunch of different things that NASA was looking at doing in its post-Apollo days. And one of those post-Apollo options was building an orbital space station, and that plan included a shuttle that would, you know, shuttle astronauts back and forth between Earth and low Earth orbit. However, Nixon okayed the shuttle, but not the space station, which is why we ended up with the shuttle doing nothing in Earth orbit. But as the shuttle developed, there were all kinds of considerations that the Department